Hello students, welcome back to the circuit analysis. I am Jayalakshmi. I am going to handle the fourth unit of your transient analysis. Let us start with that syllabus. The fourth unit is about transient analysis. In this unit, we are going to discuss natural response and forced response of the circuits given to you. And we are going to discuss the transient or natural response of RC, RL and RLC circuits excited by DC signal, that is, and step signal, impulse signal, and for exponential sources. We are going to discuss the complete response of RC, RL and RLC circuits to sinusoidal excitation. That is, we are going to discuss the series circuits of RC, RL and RLC circuits for DC and AC excitation. Let me start with that introduction about that responses. What is response? Generally, what is response? If you are given a force, what's your output? That is called as response. For same as that one, for the circuit, if you are giving an input, there should be a change in the output. If there is any change in the input, there should be a response in the output also. That is called the response. Okay, va? If the output of an electric circuit for an input varies with respect to time, then it is called as time response. The time response consists of the following two parts. One is transient response, another one is steady state response. What is transient response? For example, if you are switch on a fan, initially it starts some time to reach the speed you have put. Okay, so the time up to that it reaches to the full speed is called as transient time, we are calling. Okay, similar to that one, your circuits also take some time to reach its final position. Okay, so the time taken during which it gives some response, okay, during the time it reaches to the steady value, it's called as steady state transient time. The response of the circuit during that time is called as transient time. I will give you that by explanation. After applying an input to an electric circuit, the output takes certain time to reach steady state. The output will be in transient state till it goes to a steady state. Therefore, the response of the electric circuit during the transient state is known as transient response. The transient response will be 0 for large values of t, because for large values of t it will reach us to the steady state. That time the transient response will be 0. Okay. Next, where that transient will be present or absent. Transients occur in the response due to sudden changes in the sources that are applied to the electronic circuit or due to the switching action. Okay, that is, when you are applying some force, that time only the changes will be happen. When that forces will be applied, either you are going to switch on the fan or you are going to switch off the fan. That time only that changes will be happen. For example, if you are switch on the fan, that time it takes some time to reach us the maximum speed you are putting. Similarly, when you switch off the fan, the same thing happen. It takes some time to reach us to the off position. Okay, so this is happening in the circuits also. There are two possible switching action. That is our opening switch or closing switch. That is, opening switch means off, closing switch means on. Okay, the transient part will not present in the response of an electric circuit or a network if it contains a resistor. Okay, if in a circuit there is a resistor, means there is no transient response for resistor, because it is not it won't show any changes, abrupt changes in the voltage or current, because it adjusts itself. Okay, but in the circuit where you are having a inductor or capacitor, since they are storing the values in terms of voltage and current, they shows the response. Okay, so if a circuit contains a inductor or a capacitor or both, or if a circuit contains an inductor and resistor, resistor or capacitor, or all the three, then the circuit will have the response, transient response. Okay, next, how the inductor behave during the transient response. Assume that the switching action takes place at time t equal to 0. That is, before you are going to switch on the fan. Okay, the inductor current does not change instantly, okay, instantaneously when the switching action takes place. From 0 to 1 you are going to do, okay. So at initially 0, then you are going to close the switch. During the closing action, the current won't change in the inductor, okay. Current does not change instantaneously when the switching action takes place. That means the value of inductor current just after the switching action will be same as that of just before the switching action. That is, the current is not going to change in the inductor. IL of 0 plus will be equal to IL of 0 minus. That is what you are going to do initially. That is, before closing the switch, what you are having will be that same as when you are closing the switch, okay va. You are going to close the switch from its original position to let me take that one from position 1 to 2 means it take time to close 1 to 2, reach the 2. That time there is no change in the current value of the inductor. But when you are taking that for the capacitor behaves, instead of current changes, here the voltage won't be changed, okay. Here the voltage will be constant before and after the changes in the switch position, okay. Next, steady state response, the part of time response that remains even after the transient response has become 0. That is, for a large value of time, the transient will be going to be 0. That time you are getting the steady state response. That is, if you are switch on the fan after the transient time, that is after it reaches to the maximum speed, then it will run in the maximum speed itself. The speed time that won't be changed until it is switched off, okay. So how the inductor behaves during the steady state time? If the inductor independent source is connected to the electric circuit or network having one or more inductor and resistor for a long time, then the electric circuit or network is said to be in steady state, okay. Therefore, the energy stored in the inductors of the electric circuit is maximum or constant. For example, energy stored WL, that is inductor's energy. Inductor's energy is given by L into IL square, that is inductance into current in the inductor divided by 2, okay. It will be the maximum and it will be constant where IL is the maximum. Inductor acts as a constant current source in the steady state because the current flowing through this will be a constant and maximum, okay. The voltage across the inductor will be given by VL will be equal to L into DIL divided by DT, that will be equal to 0. That is, when the current reaches the maximum, there will be no voltage, it will be 0. So the circuit acts as a short circuit, okay. Next one, capacitor behavior. If the independent source is connected to the electric circuit or network having only one or more capacitor and a resistor, means that will be in the steady state, okay. The energy stored in the capacitor will be given by C into Vc square divided by 2, and that will be maximum for maximum Vc square, okay. So the capacitor acts as a constant voltage source in the steady state, okay, and the current flowing through the capacitor will be given by IC will be equal to C into differentiation of Vc with respect to time, that will be equal to 0. Remember that one. In inductor, the voltage will be 0. In the capacitor, the current will be 0. So the capacitor acts as a open circuit in steady state. That's all about the behavior of a inductor and capacitor for steady state and the transient state. We have discussed what is response, how the circuit behaves when you are applying a change in the source, when you are applying voltage source or current source, and we have discussed the capacitor behavior and inductor behavior during transient and steady state response. We will discuss the next topic in the next class. Thank you.